The first thing we need to do is set up the schematic editor so that our program knows what is connected to our robot. So I'm going to open schematic editor. And we are working with an NXT, so I'm going to switch to NXT. Sensor port 1 should be my HT-DC motor controller. Attached to the DC motor controller, I'm going to have 2 motors. And I'm going to name this left wheel. And my second wheel, I'm going to name right wheel. And it's important to reverse the right wheel so that way our robot does not go in circles since they're oriented in different directions. Daisy chain to my motor controller should be our servo controller. And in this program we're only going to have one servo, and that is a Tetrix 180-degree servo. Our sensors that we're going to use for this program, we have an ultrasonic sensor in port 2. We have a light sensor in port 3. And we have a touch sensor in port 4. And I'm going ahead to save and close my schematic editor. And now I can go ahead and create my program. So if I click on the Programs folder, I want to create a new VI, a new virtual instrument, and that is going to be a VI for NXT EV3 target. And I'm going to name my VI Harvester and Transporter. And I only want to work with the block diagram, so I'm going to go ahead and make that full screen. If I right click, I can bring up my tools palette, and if I push the push pin, it will stay. So the first thing we need to put down is our servo to start to initialize its position. So if I go to I/O for input/output, motors, which is actually on the right, advanced motors, and then move servos, I'm going to put that move servos block down. Then I need to tell it which servo it's using. So if I right click the top node and create a constant, I can tell my program from the drop down that I'm using the Tetrix 180-degree servo. And if I right click on the node that says position 1 and create a constant, I can tell my program to start my servo in position 150. After my program initializes the servo, I want it to wait for a second. So I'm going to go back to my main screen, my Mindstorm Robotics, input/output, and then put down a wait for block. I want it to wait for 1 second, so I'm going to create a constant of 1. And then I'm going to connect my NXT wire, which determines the order of my program. So the next thing I need to do is the rest of my program is going to run continuously, so I need to put a while loop. So I'm going to go to Programming, Structure, and While Loop, and I'm going to drag my while loop out to the right, and I can always make it bigger later with the blue dots. Inside my while loop, I need to put Screen Update Sub VI, which is a mini program that takes text values, it takes the light sensor value, and it takes the ultrasonic value. Okay, my screen update, I'm going to have it read 2 lines of text on my NXT. So on line 5 text, I'm going to create a constant, and I'm going to type in searching. And on line 6, I'm going to create a constant and type in ball count. That way on the NXT screen, I can see exactly what my program is thinking. And of course, get in the habit of connecting your NXT wire through. So the next thing I need is a touch sensor block, so input-output sensor. And I need to tell my program which port it's in by creating a constant. So this is in port 4. I can connect my NXT wire. And I want to make sure that it counts the number of times it was pressed. So I'm going to go to my drop down for the touch sensor, read NXT V3 touch, and I'm going to go to count, which changes my picture. The next thing I want is to be able to write an integer, a number, on my screen. So I'm going to go to, under Input Output, Display, and I don't want to write text, I want to write an integer. And if I create a constant on the top, I can tell my program, so I'm going to create a constant, and I'm going to tell it that it can take up to 8 lines. So connect my NXT wire. I'm going to share the count of the touch sensor with my display. So it's displaying how much, how many times my touch sensor is pressed. The next thing I need to do is my line follower program. So for my line follower program, I'm going to put 2 case structures down, and that's under Programming, Structures, and Case Structure. So I'm going to put 2 case structures down. My bigger case structure is going to have my motors, my move motors, which is input, output, move motor. And once again, I need to tell my program which motor it's using. So if I right-click, create constant on the top, I have 2. So if I click the drop-down, I'm going to have it be left wheel for red, then right wheel for blue. And if you notice, my picture changed also. But the problem is, if I leave this initialization box inside my structure, nothing else can access it. So I'm going to drag and select that initialization box, and I'm going to put it back in the front where I can easily find it. And then my wire broke, so I need to go ahead and connect back my wire. Now I need to give my motor some power. So my red motor, I'm going to create a constant of 0. And my blue motor, I'm going to create a constant of 15. But I want to have that be able to switch and share with my other structure. So I'm going to go ahead and drag the 15 into the other case structure and reconnect my wire. Now the reason that this dot is open, this blue dot, is because there's nothing in the false case at that dot also. So I'm going to create a constant at that open dot, and I'm going to have that also be a power of 15. In my false case then, of my right case structure, I'm going to go ahead and put my move motors block down again. I'm going to connect to my power wire, so my program knows what motors I'm using. And this time my powers are going to switch. So my blue motor is going to have a power of 0, and my red motor has a power of 15, which creates my line follower program. It switches back and forth. I'm going to go ahead and connect my NXT wire. So my NXT wire needs to go to the first case structure, through the case structure into the second case structure connecting to my move motor. And notice once again I have an empty node, so I need to connect it in the true structure also, the true case. But I have to have something to choose the true and false on each case. So I need to use a comparison. So I'm going to go to Programming and Comparison. And for my first case structure, I'm going to choose a greater. And then for my second case structure, I'm going to choose a less. And these are what are going to determine whether it chooses true or false for each case. So I'm going to connect my tip of my comparison to my case selectors on each one of my structures. Then I have to have a value that it's taking to compare. So I'm going to go to my screen update, and I want to take the light sense or the ultrasonic value, which is right in the middle, sonar distance, and I'm going to connect that to my grader. And that grader needs to compare to a number, so I'm going to create a constant for the y part of 40. For my second case structure for that less, I'm going to take my light sensor value on my screen update sub VI and connect that into my x part. And then I'm going to create a constant for it to compare to, and that constant is going to be 50. Of course, you need to make sure you're saving continuously, so I'm going to go ahead and Control S to save. And then the next part of my program is going to harvest the ball when it's detected. So I need to put down another case structure, and I'm going to drag that out kind of big, but I can always resize it later. And I have to have something that chooses my true and false case. So once again, I'm going to Programming and Comparison, and I'm choosing a less. And that is going to wire into my case selector. I need to back up in my program, and I want to take the value on my screen update, the sonar distance, and have that be the comparison into the less than. And I need to have a number, so I'm going to create a constant for y, and that's going to be 23. So inside my true case, this is where I need to have my robot state that it found a ball and go through the motions of actually harvesting the ball. So under input output, I want to use a display control, so display, and I want it to write text. So under the text node, I'm going to create a constant, and I'm going to type in found, which will be displayed on the NXT, so that way I know it found the ball. Connect your NXT wire for order. And once again, I have this open node, which means I need to go to the other structure, other case in the structure, and connect my NXT wire all the way through. So once it's found, I want it to break the motors. So I'm going to go ahead and put move motors down under input output. And these are the same motors that I used before, so I can go ahead and click the top node and share the power wire. Now I can't go inside the case structure. I need to be outside the case structure to be able to share. And I'm going to give the red motor a power of 0. And since they're sharing that same speed of 0, I can just connect my two wires together. So my NXT wire connects the two for order. And I'm going to go ahead under I/O and put down a wait for time, so wait for block. Connecting my NXT wire. And I'm going to create a constant of 1, so it waits for 1 second. That way I'm spacing out my program. So the next thing I need is a for loop, so I'm going to go ahead and put down under programming, structures, for loop, and drag out a for loop, which is going to let me go for a certain number of times. So I need to tell it for my loop count how many times it needs to run the program inside of the for loop. So I'm going to create a constant, and it's going to run for 120 times. Inside the for loop, this is where I'm going to move my servo. So I need input, output, motors, so advanced motors, and move servos. You have to be really careful about which motor block you're using. And this servo is the same as the one I used before, so I'm going to go ahead and click the top and go back to the last time I had a servo, so towards the beginning. Because it's going to share the same initialization box. Okay, so it's going to share this Tetrix 180 servo 1 box. In this case, I do not want it to jump to a position. I want it to slowly move to a position. So to do that, I'm going to go to my programming menu. And I'm going to go to numeric, and I want to subtract the value of 1 over and over. And to take the value of 1 over and over, I'm going to use this +1, this increment. So I need to take the loop iteration, which just means it counts every time the loop goes. So it's going to count all the way to 120. I'm going to wire that into my increment, and then that increment is going to wire into the Y part of my subtract. I need to create a constant for the X part, which is 150, and then my X less than Y, so my tip is going to go to my servo position. So what this does is it takes the position of 150 for my servo, and it subtracts 1 over and over and over to slowly move the servo to position 30, because 150 minus 120 will put it into position 30. And then I would like to have my program wait, my robot wait. So I'm going to go to input output and wait for, and in this case instead of seconds I want milliseconds. So I'm going to go time, wait for time, and milliseconds. And I'm going to create a constant of 10 seconds. Then of course I need to follow my NXT wire through for order. So continuing on with our programming of the harvester and transporter, we are working in, just got done with working in the for loop, and to the right of the for loop I'm going to put down a while loop. So that's under programming, structures, and while loop. And inside this while loop, I want to take the touch sensor and have it continuously count, continuously read the touch sensor for its counts. So that's input output I/O sensor. And I don't want a pressed, I want it to read the count of my touch sensor. So I need to change the drop down. I need to create a constant on the port to tell my program that it is in port 4. And continue on with my NXT wire to show it order. Now, anytime you have this open node for your NXT wire, we can fix that by right-clicking on the node, going to tunnel mode and last value. So that way it's taking the last value through and not auto-indexing. So I want to use the screen update to continue sending my data through. So if I go back to the beginning of my program, I can actually just copy and paste my screen update sub-VI into that while loop. And I'm going to connect my NXT wire through. So the count of the touch sensor, I need to use that to determine when my while loop stops. So I have to have a comparison. So under programming comparison, I'm going to grab a greater. So that way I can compare the count of the touch sensor. So I'm going to wire that into X. The output, so is X greater than Y, that Boolean value is going to go into my loop condition to stop the while loop. And then I need to feed a value into that greater than. And the value that I'm going to use is actually back in the beginning. It's that value I'm taking from the original touch sensor. So I'm going to take that value and use that for my greater than. So then I have a while loop that continuously checks my touch sensor to see the count, and it will stop when that count value is reached. So I'm going to expand out my windows a little bit more because the next thing I need to put down is to have my robot back up and brake. So it found the ball, it needs to back up and brake. So I'm going to put in a wait for block, so that way I'm pacing out my program and have that be a constant of 1 second. I'm going to put in my move motors, so I/O move motors, and connect my NXT wire. Now my motors are the same as the motors that I had in the beginning, the left wheel, right wheel. So I'm going to take the top part and I'm going to go back to the beginning to my initialization box. To share that same 2 motors. Okay, so here's my left wheel, right wheel. I'm going to go ahead and connect into that initialization box. And my picture should now change to represent those 2 motors. I'm going to give them a power, so create a constant of -25 speed, so that way it backs up. And I want them to share the speed, so I need to make sure and wire those 2 motors together. I'm going to have it pause again once it backs up, so I'm going to put in another wait for block. And this time I'm going to have it wait for a half a second. So I'm going to create a constant of 0.5. Once it backs up, I need it to brake, so I'm going to go ahead and put down another move motors block, and that's going to share the same motors. And I can go ahead and wire to the power wire of the last move motors, and I want to give it a constant of 0, making sure I wire those 2 motors together to share the 0, so that way it brakes. I'm doing my NXT wire for order. And then the last thing I need to do is to move my servo back to position. So I'm going to put in another for loop that's under programming, structures, and for loop. This for loop is going to have a loop count of 120, so I create a constant of 120. which means it's going to run the program inside 120 times. I want to move my servo, so I'm going to go Input, Output, Advanced Motors, and move servos. And this servo is the same as the one before, so I can actually connect the top port to the last servo that I see, as long as I don't go inside the for loop. And I need to have something that changes my position. So I'm going to take a comparison. I'm going to go ahead and take my, I'm going to take my programming numeric, and I'm going to go to the add. And then also, I want to have it move to position slowly, so I want it to add 1 over and over. So I'm going to go to programming and numeric again, and I'm going to use the increment, so the +1. So I need to go from my loop iteration, which takes the count of the for loop, into my increment. My increment is going to my add, and I need it to be able to add to some number. So in this case, I'm going to create a constant for x, which is going to be 30. And that x plus y is going to go into the position for my servo. I also want it to wait after it's done. So I'm going to go to Input Output, Wait For, and I'm going to give this one a time. I want to change my wait for time to milliseconds instead of seconds, so I went to the drop down and create a constant of 10 milliseconds. So don't forget to connect your NXT wire all the way through. So that's going to move my servo back to position, and then the very last thing I'm going to have it, after it's moved its servo, to go ahead and wait. So I'm going to take my input output, my wait for block, connect my NXT wire. Once again, if your node is broken or open, that means it's auto-indexing. So go ahead and right-click the node, go to tunnel mode and last value. And then I want my wait for block to have a constant of 1 second. So right now there's not anything that's stopping my big loop, my big while loop. So I need to have something stop it by using the loop condition. So I'm just going to go ahead and go to Input Output Sensor and put that down next to my loop condition. Make sure that you are outside the case structure but still inside the while loop. I'm going to go to my drop down and I want to go to Read Brick Buttons, which allows me to use my NXT buttons and connect that yes, no, that Boolean value to my loop condition, which is going to stop my entire program. Your false case of the entire program should just be empty, so there's nothing in my false case, because we did the line follower program in front of that big case structure. So there's nothing in my false case. So make sure and save, and after you run your robot, you will have to double check the values of your servo. So using Schematic Editor, you can connect and check the values of your servo and go through and tweak them in your program. So if I clean up my diagram a little bit, this is what my entire program looks like. And I know I have no errors because my run arrow at the top is solid.